Hello everyone, welcome to my chemistry channel BL the Short and Sweet in Chemistry. Now I am going to explain the topic, that is short revision in electrochemistry, and here the chapter, that is one, molar conductivity of electrolytic solution. Listen again, molar conductivity of electrolytic solution. This is part 13a and class, that is 12th class. So first we will see what is electrolytic conductance. That means here electric current is there, and that substance that is a conducting electricity, so conductance. Molar conductivity, molar. Mole mean 1 mole of substance. What is mean? That is gram molecular weight equal to 1 mole. So molar conductivity, that means the ions having 1 mole, 1 molar, 1 m, then it is molar conductivity. If 1 mole, 1 molar, that means gram molecular mass. So here factors, what are the factors affecting the electrolytic conductance? Actually, if you see in aqueous solution or molten state, that means if a salt that is in molten state, you know it conduct electricity. In aqueous solution of electrolyte, that also conduct electricity. That means here the electrolyte split off. The electrolyte in water or electrolyte in molten state, they split up into opposite ions. Let it is sodium chloride. What you will get? Na plus Cl minus. That means opposite ions that are splitting. Free movement of ion is responsible. These ions which are in the aqueous solution or molten state, their movement is free. Free movement of ions is responsible for the conduction of electricity. Conducting electricity means which is responsible? Movement of ion. And movement of ion, that means opposite ions are produced when in aqueous solution stage or molten stage. Second, nature of electrolyte. Some electrolyte which are very strong electrolyte. That what is strong electrolyte? Means ionize into a large extent. Higher electrical conductivity, that means it conducts electric high, and stronger electrolyte, that means ionization is more, greater extent, larger extent. But when you see weak electrolyte, they have low degree of ionization. When you will read strong electrolyte and weak electrolyte, at that time you can differentiate between strong electrolyte and weak electrolyte. But here you know stronger electrolyte when added to water or in molten state, they have ionized to a large extent. So it conduct electricity higher. Conductance is higher, conductivity is higher. Weak electrolyte, that is less, degree of ionization is less. That means ions are less. That means lower electrical conductivity, not so high as your strong electrolyte. Then that next one, size of cation. Size of cation and their solution. So here size of ions and their solution. If ions more, then what happen? Solvation. Solvation means how much solute particles are dissolved in water, and here you can say the solvation is high or less. So the salt that is dissolved in water more, that is called more solvation. More solvation means strong electrolyte gives more ions. Solvation refers attraction between the ions of electrolyte. That means electrolyte generally an ionic compound, they gives ions having positive and negative charge, and here solvation means the attraction between the ions. Larger the charge and size ratio of the ion, larger is the extent of solvation. So solvation meaning depends on the charge by size ratio. You see the charge with the +2 or +1 or +3. Size mean you will see put the value of size. This ratio of the ion larger the extent of solvation. If it is the ratio value is larger, then solvation is high. If lower, the electroconductivity of the lower when the electrical conductivity of electrolyte. That means if the charge by size ratio is higher, then extend solvation. If it is lower, the electroconductivity of electrolyte also lower. Nature of solvent and viscosity. Nature of solvent. Some solvent which are very fluidity nature, it can flow easily. When viscosity increases, then what happens? The fluidity less and that will not flow easily, and here density you can say of fluidity power that is very less. Just like you can see example water and here any oil. Water that fluidity is more, that means viscosity is very less. But in oil viscosity more than that water, this polar solvent cause larger ionization. Then question is, what is meant by polar solvent? Polar solvent means where there is a plus and minus, that is a charge is there. This is called polar solvent that have large ionization of the electrolyte and increases the electrical conductance of electrolyte. Then polar solvent, example water is the best example. If R in water, they give large ionization of the electrolyte. Also increases the large electrical conductance of the electrolyte. So if the viscosity is more, fluidity power is less. If I told viscosity high power of fluidity, wrong. Viscosity means low power of fluidity. Fluidity decreases when viscosity increases. So larger viscosity of the solvent, the lower will the ionic movement, because it will not ionize completely. It ionize is not so high because fluidity is less, viscosity is larger. That means it will not flow easily. It not dissolve any salt that dissolve easily in the larger viscosity solvent. So the ionic conductance, the ionic power is less, smaller is the electric conductance of the electrolyte. Again see what I want to explain, nature of solvent and viscosity. Nature of solvent means one is polar solvent, another is organic solvent. Now organic solvent what is not required, polar solvent, and they cause large ionization of the electrolyte because they can break easily. If it is more ionization, then what happens? It increases the electrical conductance. And if the larger viscosity, that means the fluidity power is less. That means large viscosity. And the solvent here, what happens? Ionic movement is very low. Smaller will the electrical conductance. That means if solvent is polar solvent, the electrolytic the conductance is high. If the viscosity is more and it is low, very low or smaller electrical conductance. I think it is clear. Then concentration of the solution. What do we mean by concentration? That means what is the amount of solute in water. If it is low concentration, that means when the solute particle or electrolyte, if say very less and more water, that is called low concentration. If the salt or electrolyte, if you say it is very high and less water, then it is called higher concentration. So salt, the smaller will be the electroconductivity. That means if the higher concentration, the electrical conductance very less, smaller. Weak electric conductance ionize to a smaller extent in more concentrated solution. A weak electrolyte also ionize to a small extent. Why? because here, since it is weak electrolyte, it cannot ionize completely or ionize to very small extent. Then here in more concentrated solution. So in both case, weak electrolyte ionize that in electrical conductance is very small, but due to different cause. Strong electrolyte do ionize to a large extent. See, strong electrolyte, if it is there, do ionize to a large extent, and here interionic distance, interionic attraction are high because one is positive, another is negative. The both ions are there, and that is a ionic compound. So when dissolved in water, then here they will ionize in large extent, but interionic attraction is high. If interionic attraction is very high, then electrical conductance that also decreases. As the concentration decreases, now what I told, if it is increases, now extent, larger extent. Now the second one, what I want to say in C, if the concentration decreases, then what happens? Ionization of electrolyte increases, and here the interionic distance that is very far away. That means here, if the concentration decreases, ionization increases, and in case of strong electrolyte, interionic attraction decreases, so increases electrical conductivity. So strong electrolyte, when here concentration is less, and also increases electrical conductivity. Then temperature. Increases temperature causes increased ionization. Now, when you add a strong electrolyte in water, forget the concentration. Here only you see if temperature increases, what happens? Then ionization movement increases, and that is movement increases. Then here electroconductivity of solution increases with temperature. So sometimes in practical, in experiment, here it is observed by increasing the temperature, increase the ionization and movement of ion, so conductivity, electric conductivity increases. After electroconductivity, you can say what is molar conductivity of electrolytic solution. Molar conductivity means what is related? In molar conductivity of electrolytic solution, the conductivity of metallic conductor. See, metallic conductor, very important. You can say here metallic conductor has a definite value at a given temperature. So it has already calculated what conductivity of this particular conductor, that means metallic conductor, the definite value has a definite value. It is already proved, and you should remember what is the value of silver, aluminum, copper, like this. But in electrolytic solution, so when it comes to electrolytic solution, not about metallic conductor, then what happened? The conductivity not only depends on temperature, but also varies with the concentration. Before that, only depend on the temperature of the metal, but here with the concentration of the solution. The conductivity of solution is attributed due to presence of ions. If as it is an electrolytic solution, and here what happened, which is responsible for the conductivity, that is ions. So presence of ions in a solution is very important, and how they are attracted to each other, what is the interionic distance between them, all are the main important for the conductivity. Equivalent conductance. Before that, what is that one? Molar conductivity of electrolytic solution, and here it is equivalent conductance. What is meant by equivalent conductance? Molar conductance related to mole. Mole. What is mole? Mole is gram molecular weight. Suppose sodium. Sodium means what is the Suppose 1 mole mean 40 gram. Like this. Here molar conductivity mean molarity mean mole mean gram molecular weight. If it is electrolytic solution, sodium hydroxide, then what is 1 mole? 1 mole equal to 40 gram. 40 gram mean 1 mole. So 1 mole per 1 liter, that is molarity. 1 m, that is 1 m. So here you should know what is the mole of the your electrolyte, then how much water is dissolved, all the things it can help you to calculate molar conductivity. Later we will see in clear. Equivalent conductance, it is defined as the conductance of all the ions. Remember, all the ions where it is produced by 1 gram equivalent of an electrolyte. That means gram equivalent weight of an electrolyte you should know. According to the calculation, here the conductance, that means what are the ions produced by 1 gram of equivalent of the electrolyte in a given solution, and that is remembered by lambda E. And the equivalent conductance equal to kappa into 1000 by E. E means equivalent weight. So that means you can put instead of E, N. N means normality. So unit of equivalent conductance, that is equal to, what is that one? Ohm minus 1 inverse, you can say Cm square equivalent minus 1. So molar, then I am coming to particular molar conductance. What is this equivalent? That means you have seen equivalent conductance. Now you will see molar conductance. So this is known as equivalent conductance. This is kappa. This is equivalent weight. This is normality. Molar conductance means solution defined is the conductance of all the ions produced in ionization of the 1 mole of electrolyte. So here you will see it is denoted by lambda m. M means molar conductance. E means equivalent conductance. This is equal to kappa into V. V means volume of the electrolytic solution containing 1 gram mole of the electrolyte. So V equal to 1000 by M. M means molarity. So from 1 and 2, and what you will get equation number 3. Then lambda M equal molar conductance equal to kappa into 1000 by M. Then what is the unit? The unit equal to unit is ohm minus 1, that is inverse, ohm inverse Cm square mole. So now we will see SI unit of molar conductance. What is SI unit of molar conductance? That is equal to Simon M minus 1 L mole minus 1. Then here 1 S M square mole minus 1. That is equal to here 10 to the power 4 as Cm. M equal to here Cm square mole inverse. So here what you will see, or 1s instead of meter, if you put Cm square, 1s Cm square mole inverse. So you can put here 10 to the power minus 4 as M square mole inverse. Again see, SI unit of molar conductance equal to Sm minus 1 L mole minus 1. That means you can put 1 meter square, that means 10 to the power 4. And that is Cm square, 2 times, so 10 to the power 4 as Cm square. that is mole. Here you can see 10 to the power 4 as cm square mole inverse. Or you can say in terms of centimeter, 1 s that equal to 1 s cm square mole inverse equal to 10 to the power minus 4 s m square mole minus. It is very difficult one. Try to understand by reading 2-3 times. S means Simon, M means meter, L means liter. M means meter, L means liter, MOL, mole. That means you put accordingly to the calculation. The resistivity of the solution, this is the concentration given in question, and the resistivity is also given in question. And then what happened here? Then rho equal to value is there 5 into 10 to the minus 3 rho cm. Concentration also given. So rho is given, concentration given. Then what is conductivity? Conductivity equal to 1 by rho. Conductivity equal to kappa. Then here it is known as kappa. So here what happened? Here what happened? Kappa equal to 1 by rho. 1 by rho value put here, and that is the all calculation value. And next come to molar conductivity, because here you can get kappa. And next molar conductance equal to 1000 kappa by m. M is given in question, and kappa you have calculated this value. So this value you have calculated, and you put the value lastly lambda m, that is molar conductivity calculated. This is the value. Units of molar conductance here kappa, and this is the concentration, this is the unit, this is the unit. Then divided molarity, molar equal to mole by dmq or cmq. After calculating all, you will get this is the unit of S Simon, cm centimeter, mole, and here changes to ohm minus cm square. Instead of Simon, you can write ohm minus and mole minus. This is the unit, SI unit. An explanation for the variation molar conductivity. Weak electrolyte. First you will see weak electrolyte, then you will see strong electrolyte. Weak electrolyte, low degree of ionization. They have a poor ionization in aqueous solution, which is responsible for the low value of molar conductivity. Remember, weak electrolyte never ionize completely, and here that is the main cause, where poor ionization, that is cause for the low value of molar conductance. When the dilution increases, what happens? Degree of ionization of weak electrolyte also increases, causing more and more ionization. Weak electrolyte and strong electrolyte both will degree of ionization increases, and causing more and more ionization. The value molar conductance also increases on dilution. When the concentration approaches 0, if diluted more and more, then what happens? Concentration lastly approaches to 0. Degree of ionization, that is nil. Degree of ionization here, the electrolyte almost undergo complete ionization. Means weak electrolyte, if you make ionization and more increases the ionization due to dilution. If dilution is more and more, and degree of ionization, that value come to approach to unit. Unit means 1. So here this value is unit 1. Then what happened? The electrolyte almost completely ionized. This caused steep rise in the value of molar conductance near at infinite dilution. When the concentration approaches to 0, more and more dilution proceeding, degree of ionization approaches to unit, then here you can say this is the infinite dilution. But when you see for strong electrolyte, what happens? Strong electrolyte from the beginning completely ionized, and all the concentration, all infinite dilution or concentration, this is completely ionized. That means here what happened? Molar conductance are high at high concentration and also on dilution. In concentration solution of strong electrolyte, the density of ions is equally high, result the significant interionic attraction when the concentration solution is more, though they are completely ionized, but there is a strong interionic attraction between the ions. This result reduce the interionic attraction, reduce the speed of the ion, movement of the ions are responsible for the low value of molar conductance at higher concentration. So this is the main question. When it is a strong electrolyte is at high concentration, there should be more and more molar conductance. But why not? Because there is an interionic attraction is there strong that reduce the speed of the ions, so it is lower the value of molar conductance. But what happened? Dilution. On dilution, here the ions are separated far away each other by the help of water molecules. The ions more apart and interionic attraction decrease. Interionic attraction decrease, so molar conductance increases. Are you clear? That means strong electrolyte, there is a interionic distance is less. When in dilution, interionic distance is far away, and so the molar conductance increases. Mathematical relation between and this molar conductance and molar conductance at a infinite dilution. For strong electrolyte was developed by this the scientist Dubin, Huckel and Ansgar, equation it is called, and that developed that this meaning molar conductance and infinite dilution. For that there is a equation, very simple equation, and molar conductance equal to molar conductance at infinite dilution and minus A root over C. C means concentration. A is a constant depending on the nature of the solvent temperature, and here see the molar concentration of the electrolyte from equation. Here you will see what is the graph. As the C approaches to 0, then when concentration approaches to 0, that means at infinite dilution, then it is lambda m molar conductance equal to lambda m0 infinite dilution. The plot that is molar conductance versus C to the power half, that is root over C, should give a straight line with slope equal to minus A and intercept equal to molar conductance at infinite dilution. So the graph between C root over and molar conductance. This is the graph where you will get a straight line and having intercept of lambda m0 and the slope equal to A minus 1. So this is the graph you can observe, and what is the value of all. So here the lambda m, where the unit is S means Simon, cm square mole inverse, and C root over, that is root C, that is mole L to the power minus 1. This is the unit. First of all, you will see the graph having intercept how much? Lambda m0, and suppose, and here this slope equal to minus A. I hope it is clear to you. a little bit difficult in this chapter regarding molar conductance, equivalent conductance, all are related, and how on dilution both this one increases. Molar concentration of electrolyte C, if increases, the molar conductance of weak electrolyte also increases, and strong electrolyte also increases. But what is the cause? The cause for both cases are different, and hope you will clear about this chapter. And I am Mrs. B.L. Das, ex-PGT Chemistry, and my YouTube channel is BL Das Short and Sweet in Chemistry. Thanks for watching my video. Thanks again to all.